at what I noticed. Circle A and B have congruent radii. So I know that circle A and circle B, so these two are congruent. That already tells me that this is going to be a perpendicular bisector. Okay? And I also know that circle G and circle I have congruent radii. So here's G and here's I. So they have, and there I can see the perpendicular bisector there. Okay, so let's see what I have. AD is perpendicular to BL. AD is perpendicular to BL. Yes, we just determined that. That's true. FJ, that's at the top circle, is perpendicular to BL. We just determined that. Those are perpendicular bisectors. We can see them up here. If these are equal, then we cut it in half. AB is parallel to FJ. Well, if this is 90 degrees and this is 90 degrees, then these have to be parallel. And my final one says angle HBC, that's this angle right here, is that congruent to angle MLO? It might be, but I don't think so, because this is a short radii, this is a long radii. I don't know that for sure. I'm going to say false. Okay? If these were the same radii, I'd say yes, but they're not the same. Okay, turning the page. Look at the figures below. JK, here are our lines. Select all if line K is perpendicular to L. So I know that K is perpendicular to L. That makes 4 90 degrees. That makes 1 90 degrees. 2 and 3 together make 90 degrees. And 5 and 6 together make 90 degrees. So let's see. It says angle 5 is 90 degrees. No, that can't be. 5 must equal 6. I don't know. They could be 30 and 60. No. Angle 4, yes, that's 90 degrees. Angle 5 plus 6, yes, that's 90 degrees. Angle 4 plus 5, no. Angle 4 must equal angle 6. No. The only thing I know is vertical angles and then all the things that equal 90. Okay. The pre-image of DEF is reflected across the X. So let's go reflect it. All right, so this goes up 1, down 1, up 1, 2, 3, down 1, 2, 3. And up 5, and we'll say down 5. Okay, so there's what we have so far. To create D prime, okay, which of the following statements are true? Based on this. The perimeter is the same. Yep, the perimeter is the same. The coordinates of D are the exact same thing as the coordinates of D prime. No. The length of DE is the same as, yep, this length equals this length. The areas are the same. So 3 things the same. The coordinates aren't the same, but we just reflected it over. It's a rigid shape. Okay. It says this one is going to be reflected across y equals -1. All right, so here's my y equals -1. And then it's going to be rotated 180 degrees. So let's just go do one at a time. So down 2, up 2, down 2, 1, 2, 3, 1, 2, 3. There's y. 1, 2, 3, 4. 1, 2, 3, 4. There's w. And x was 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's x. There's my originals. Okay, my original, now my new. After I went, now it says rotate 180 degrees. Okay, well, this is where you got to decide. Do you want to rotate your paper or do you know the rule? I know the rule, but I'll rotate it. So if I rotate my paper, I know my final x is going to be at back 1, up 1, 2, 3. Okay, so my final z is going to be, so it's going to be back 1, 3. So back 1, 1, 2, 3. There's my Z. We can call it double prime or prime. I don't care. Okay, I think they only want you to do the final. All right, my new Y, when I flipped it over, becomes 2, 4. So again, if I flipped it, it originally was 2, -4. Now it's back 2, up 4. So what I noticed was back 2, up 4. I'm just switching my signs here. So there's my new Y prime. My W was at -2, -5. So now it's going to go from this to this. So it's going to be 2, 5. And my X was back 1, down 6, will be forward 1, up 6. And again, you can turn the paper the entire time. Okay. So we did it. We graphed it. Here it is. Determine the rule to get from XYZ onto X prime, double prime. Okay, we're looking for a rule here. What did we do first? Again, if you can't figure this out, that is always going to be my suggestion. Okay? So take one of the letters and figure it out. I'm actually going to do 2. I'm going to do the W and I'm going to do the X just so we have 2. My original W was at -2, up 4. Okay. No, it was up 3, sorry. And then it went to -2, down 5. And then my final place for W was 2, 5. Okay. So here's what I think the rule is. I think my X stays the same till I get to here. It's going to flip over. First, my Y had 3. It somehow got to -5. So at first I was like, well, did I take away 8? What did I do? I know I flipped it. So I think it's going to be a -Y. So this was my XY. Change the -Y, and then that would make it -3, then take away 2 more. And then I'm going to flip these because it goes from negatives to positive. This becomes Y plus 2, which makes sense. Let's see. -2 to +2, and 3 plus 2 is 5. Let's see if the same thing worked with X. We'll just look at the first and the last. We don't even need the middle. How did you get from the first to the last? Okay, my original X was at -1, up 4. And my final X was at +1, up 6. So let's see if it worked. Flip the X, add 2 to the Y. Yes, it did. Then you know you did it right. Okay, this is when you need your compass. Maria and Anna want to meet up at a certain point. There are three stores near their house. Construct a perpendicular bisector for the line connecting Anna's house and Maria's house. Okay, so the first thing we need to do is make a line connecting Anna and Maria's house. And then we're making the perpendicular bisector. Remember, put the compass on one end and then switch it to the other end. And if you look at me, okay, so we just made the perpendicular bisector. Okay. Identify the store that is equidistant from their houses. Well, B, because it's on the perpendicular bisector. B, because B to Anna's and B to Maria's is equal. Look, it's on the perpendicular bisector. B is on perpendicular bisector. There you go. Determine which polygons are congruent. Okay. So I'm looking here. The two that look alike are this one and this one. So I said A, B, C, D is congruent to, now which goes with A? A went with M. B is an obtuse. P is an obtuse. C and O, and then N, and so my guess is we rotate 180 degrees. So let's see, let's make sure. We went back 2, up 3. So the opposite would be forward 2, down 3. So O went with C. That's exactly what we said. B was back 3, up 5. The opposite would be positive 3, down 5. So P should have gone with B. Yep, there we go. Use what you know to explain why the two compute there. It has a rigid transformation. Rotate 180 degrees around 0, 0. Technically, you could have also said it reflected, then reflected. I know it couldn't be this one, 2 right angles. Okay? All right. Okay, last page. Does SML and KL meet the side, side, side criteria? That's what I'm looking for. So here's my given. Here's my statement. Here's my reason. My given is that SM is congruent to KL. So this one and this one are congruent. And it says KM is congruent to SL. Those are my givens. That KM, the diagonal, is congruent to SL. Okay. The way this is written right now, do we have any other things that we could use? And what we're trying to figure out is, does triangle, let me look at the one they want, SML, this one, equal KML? And I see right now, I highlighted this as both pink and green, which means ML is congruent to ML, which is reflexive. Therefore, my answer is yes, but not because of side, side, side. Oh, yeah, there we go. Side, side, side. There we go. And we know triangle SML is congruent to triangle KLM. Side, side, side. All right, my last one. Do these two meet side angle side? So we want side angle side. So let's just see what we got. We know that T is midpoint of SC and PM. That's my given. So there's my statement. Here's my reason. Okay, I know that T is in the middle of this. That makes those equal. It's also T is in the middle of this, which makes those equal. So now I already know that ST is congruent to CT, and I also know that PT is congruent to MT. And both of those are definition of midpoint, definition of midpoint. And now here's my angle. And I can go label this, but I think it's easier just to call them angle 1 and angle 2. Angle 1 is congruent to angle 2. We can't call them angle T. This is an angle T, this is an angle T, this is an angle T, this is an angle T. Too many angle T's. You can get MTS, CTP, or you can label them as angle 1 and 2. And we know they're equal because they are vertical angles. So therefore, we have side, angle, side. Here's my side, and my angle. So yep, triangle MST is congruent, I'm moving it up, to triangle PCT. If you have questions, make sure you come to the check-in.